This is October-November 2019 session of paper 4 variant 1 0620 chemistry. Question number 1. This question is about ions and ionic compounds. Choose from the following list of ions to answer the questions. Each ion may be used once, more than once, or not at all. State which ion 1 gives a lilac color in a flame test. Alright, so this is the potassium ion over here. Okay, so we have potassium ion for this one. Part 2 forms a gray-green precipitate with aqueous ammonia. So ammonium chromate is the precipitate which is gray-green in color. So we have the chromate ion for this one. Part 3 forms a white precipitate with aqueous sodium hydroxide, and this one is the calcium ion and the charge of 2+. Part 4 forms a cream precipitate with aqueous silver nitrate, acidified aqueous silver nitrate, and this is the bromide ion. And the last one forms a white precipitate with acidified aqueous barium nitrate, and this one is the sulfate ion. Okay. Right. B. Describe how to do a flame test on a sample of salt. So this is quite simple. We just placed the salt to be tested on the nichrome wire and place it on top of the flame on a Bunsen burner. So right. C. Magnesium phosphate contains magnesium ions and phosphate ions. Deduce the formula of magnesium phosphate. Alright. So in order to deduce the formula, first off we're supposed to write the symbols. Alright, this is just one method which you can use. And then we write the valency of each element or the ion. Alright, so I've written 2 for magnesium and 3 for the phosphate ion, and then we cross these valencies and the elements or the ions. Okay, so now in the formula we'll be having 3 atoms of magnesium and 2 phosphate ions. So here we have the magnesium phosphate formula. So this is Mg3 and 2 phosphate ions. Okay, question number 2. A. Sulfur exists as a number of different isotopes. What is meant by the term isotopes? Alright, so they are atoms of an element with the same number of protons, but they have different number of neutrons. Okay, part 2. Part B. A sulfide ion has a symbol shown. How many neutrons are contained in this sulfide ion? So neutron is the mass number when we get the number of neutrons in any element or ion when we subtract the atomic number, which is 16 in here over here. We subtract this number from the mass number, which is 34 over here. So 34 minus 16 over here gives us the number 18. So we have 18 neutrons in this sulfide ion or atom, since the number of neutrons never changes for ions. Okay, part 2. How is a sulfide ion formed from a sulfur atom. So since we here have a charge of 2 negative, it indicates that we have 2 more electrons. Now this happens when any atom gains electrons. So simply we can write the element sulfur atom has gained 2 electrons. Okay, part 3. Which element forms an ion with a 2 plus charge that has the same number of electrons as the sulfide ion? Okay, so the sulfur element has an atomic number of 16, but since we have a charge over here of negative 2, that means it has a total of 18 electrons. And the question is asking us which element forms an ion with a 2 plus charge that has the same number of electrons as the sulfide ion. So it's supposed to be having 18 electrons after it has become the charge of after it has gained the charge of 2 plus. So it is supposed to have naturally occurring in the periodic table, it is supposed to be having an atomic number of 20, and that is the calcium element. Okay, moving on to part C. The manufacture of sulfuric acid by the contact process occurs in 4 stages, and so we have got the 4 stages over here. Molten sulfur is burned in air to produce sulfur dioxide gas, and then it is reacted with oxygen to further form sulfur trioxide, which is then combined with sulfuric acid to form oleum, and then we add water to make it a dilute version and turn it into sulfuric acid. Part 1. Complete the chemical equation for the stage 1 by adding the appropriate symbols. Alright, so we have here in the first stage, since we have molten sulfur, it's going to be in liquid form. Okay, and oxygen exists in the form of gas, and then we have sulfur dioxide also in the form of gas. Part 2. Name the catalyst used in stage 2 and the temperature used. Okay, so we have the catalyst in the form of vanadium oxide. Alright, vanadium has the valency 5 over here. And the temperature used is 450 degrees Celsius. That's it. Part 3. Write chemical equations for the reactions in stage 3 and 4. Okay, so stage 3 is sulfur trioxide is combined with concentrated sulfuric acid to form oleum. Okay, so we have sulfur trioxide combined with sulfuric acid to form oleum, which has the formula. And as we can see over here, the number of hydrogen is balanced on both sides. However, and also the number of sulfur, as we have 2 on the reactant product side as well as on the reactant side, and the number of oxygen is also balanced. And then moving on to part 4, stage 4. So this oleum reacts with water. Okay, so oleum reacts with water, and then it gives us sulfuric acid. Now we have to balance this equation. So we have 4 hydrogen atoms on the reactant side. Let's equate it over here as well. So this gives us 2 sulfur atoms on both sides and 8 atoms of oxygen on both sides as well. D. Sulfur dioxide is a toxic gas. Part 1. State 1 environmental reason why sulfur dioxide should not be released into the atmosphere. Okay, so it causes acid rain. And part 2, describe the test for sulfur dioxide. The test is so when this gas sulfur dioxide is bubbled into potassium manganate, the solution turns from purple to colorless. So we can use potassium manganate for the test. And the important part over here is mentioning the word aqueous potassium manganate. Since sulfur dioxide is supposed to be gas, so we need a liquid to test it. Alright, it turns from purple to colorless. Okay. Moving on to part E. Sulfur dioxide reacts with aqueous sodium sulfide to produce a compound with the following composition by mass: 29.1% sodium, 40.5% sulfur, and 30.4% oxygen. Calculate the empirical formula of this compound. Okay, so to calculate the empirical formula, let's start with writing the symbols of the elements. We have sodium, sulfur, and oxygen. Now we're supposed to calculate the number of moles. So for the number of moles, we're supposed to have the mass and the molecular mass. In this case, we're going to be using the percentage as the mass over here. So we divide 29.1 with the molecular mass of sodium, which molecular mass or relative, not molecular mass, in this case we only have elements, so we'll divide it with the relative atomic mass, which sodium has as 23, and we divide the percentage of sulfur with its relative atomic mass being 32, and then we divide the percentage of oxygen with its relative atomic mass of 16, and so we have the number of moles as this. I'm only writing a few significant figures: 1.268 and then 1.9, and now we're supposed to calculate the ratio, and to do so, okay, this is 1.265 over here, 1.268 for sulfur, and 1.9 for oxygen. So for calculating the ratio, we're supposed to divide all of these three numbers with the least value in them, which is 1.265, and when we divide this, we get the ratio as 1:1:1.5. And since 1.5 is not a whole number, we're going to convert it into a whole number and multiply all of the three values with 2, which gives us the last values as 2:2:3. So we have 2 sodium atoms, 2 sulfur atoms, and 3 oxygen atoms. So we have the formula as Na2S2O3. Alright, that's it. Okay, moving on to question number 3. This question is about metals and metal oxides. A. Most metals have a high melting point. State one other physical property that all metals have. Alright, so we have a lot of properties over here. I'll write they all conduct electricity. B. Iron often rusts. Name the 2 substances other than iron that must be present for iron to rust, and those 2 elements or substances rather are water and oxygen. C. Iron can be obtained by heating iron 3 oxide with zinc powder. 1. What can be deduced about the reactivity of zinc from this reaction? Alright, so we had zinc as an element over here, and we have iron in the compound in the form of iron oxide compound. So zinc here displaces iron, which means zinc must be more reactive than iron to have displaced it. So this tells us that zinc is more reactive than iron. Part 2. The Ionic equation for the reaction is shown. Identify the oxidizing agent in this reaction. Explain your answers in terms of electron transfer. Okay, so oxidizing agent is always the substance or the ion or element which is reduced, that is, it gains electrons. So in this case we have iron which gains electrons. We can figure this out when we look at the ion state. Over here its ionic state is 3 plus. So it becomes from an ion to an atom, sorry, an atom. So the 3 plus charge is cancelled when it gains 3 electrons. So in this case we have iron as the oxidizing agent, or rather the iron 3 plus, and the reason is that it gains electrons, or it is reduced. Part D. Zinc oxide is amphoteric. Describe two simple experiments to show that zinc oxide is amphoteric. Name the reagents you would use and describe observations you would make. So, amphoteric substances are those that react with both acid and alkali and they form salts. So, you can write, we can use the alright, so we're supposed to name the acids and alkali which we'll be using in the form of reagents over here. So we add sodium hydroxide and zinc oxide dissolves or it reacts. And the other reagent can be hydrochloric acid. And it dissolves here as well. Okay, we're done with this question. Okay, moving on to question number 4. Insoluble salts can be made by precipitation reactions. A student mixed solutions of some soluble salts. The results the student obtained are shown in the table. Alright, so we have we have 3 salts in the form of aqueous solutions, and then the student mixed them and formed some precipitates. All sodium salts are soluble in water. Use only results from the table to answer the following questions. A. Name an insoluble cobalt salt. Alright, so here we have the only salt having cobalt precipitate here is this one, which is the purple precipitate, and to name them we are supposed to take the cobalt from here and then the non-metal ion, which is carbonate, over here. So this gives us the name as cobalt carbonate. Part 2, an insoluble yellow lead salt. Alright, so we have lead over here, and all of these salts are insoluble since they are precipitates. And the yellow one is this one, which is formed when lead nitrate reacts with sodium iodide. So we have lead iodide over here. Okay, moving on to part B, write the chemical equation for the reaction in which silver carbonate is formed. Okay, so silver carbonate, we have silver over here and the carbonate ion over here. Okay, so this is when a silver nitrate reacts with sodium carbonate. Okay, so we will have silver nitrate reacting with sodium carbonate. and then it forms silver carbonate. And over here we're using the same steps we used previously to form the formulas. Okay, I'm gonna write it over here. So carbonate ion has a charge of 2 minus, and silver only has a charge of plus 1. So when we cross this, we get two atoms of silver and a single ion of carbonate. So we get the formula as silver carbonate, and then we have the other product is sodium nitrate. Sodium and nitrate ion both have a charge of 1. So we are not going to be adding any other numbers. We'll simply have the atoms written this way. But on the reactant side we have two sodium atoms, so we're going to be equating it by writing 2 over here, and we have which gives us two nitrogen atoms and 6 oxygen atoms over here. And when we add 3 over here, so we get 9 oxygen atoms. We can balance it by writing 2 on the reactant side of silver nitrate. This balances the number of silver as well, which we had 2 on the product side earlier. Alright, moving on to part C. Write the ionic equation for the reaction in which lead iodide is formed. Okay, so lead iodide forms in this one. So lead nitrate reacts with sodium iodide, and since the result is lead iodide, we're only supposed to write the ions of lead and iodine reacting. So we have the ions as lead and the iodide ion, but it exists in the we have two iodide ions because each iodide ion only has -1 charge. So we need two charges, two iodide ions to cancel this 2 plus charge of a single lead ion. So this gives us the compound lead iodide. Okay. Part D. Aqueous silver nitrate produces a yellow precipitate with both iodide ions and carbonate ions. When testing an unknown solution for iodide ions, the aqueous silver nitrate is acidified. Explain why the aqueous silver nitrate is acidified. So it reacts with the carbonate ions and so it removes it. And that's the answer. It removes the carbonate ions. Okay, moving on to question number 5a. Question number 5a. Part of the structure of synthetic polymer A is shown. 1. What type of synthetic polymer is A? Since we can see over here the monomer unit is repeated, so this means we have the polymer from addition polymerization. So this is an addition polymer. D. Deduce the empirical formula of A. Okay, so I want to underline the polymer in here first. We in each polymer we are supposed to have at least one double bond between two carbon atoms in the backbone chain, which is this one, I suppose. And so this one is the monomer unit. Okay, so when we look at the number of carbon over here, it is 6, and the number of hydrogen over here is 12, and then when we simplify it, it becomes CH2. So we have the empirical formula as CH2.